Here we go. Okay, we're going to start another section now called stacks and queues. And this is going to be the last of the really simple data structures in this course. We'll start with the stack first. I'll explain theoretically what both of these things do, and then we'll talk a little bit more in depth about this one today. And we'll on Wednesday, there's no lecture. I'm just going to tell you a story about Masada, and we'll talk a little bit about that, and then you'll just have a lot of free time on Wednesday. Let's talk about stacks, though, for a second. My wife complains to me that when she goes into our closet, I have this pile of T-shirts, right? So there's this pile of T-shirts, and I only wear like the first three. See, I take these off, I wear them, they go in the laundry, and then after the laundry's done, we put them back here, and then these ones down here, they never get worn. So she wants me to throw out these 3 T-shirts. I'm like, no. So what's happening here in computer science lingo is called a LIFO problem. Does anybody know what LIFO stands for? Yes, sir? Last in, first out. Last in, first out. This sort of situation also happens in an elevator. So if you have like a long, thin elevator, and here's the door here, people pile into the elevator, and then when it's time to get out, the only person sometimes they can get out is the person that's closest to the front of the elevator. So like they may need to leave in order to let you out if you're in the back and you're going out earlier than they are. That's another last in, first out problem. See that? Now this is different than another situation which we talk about, which is called FIFO. And as you've probably guessed, that stands for first in, first out. Can someone give me an example in life of something where it's first in, first out? Mr. Ben.
Line at some point.
Okay, so let's say you go to a line at a bank, right? So here, let's say there are 3 tellers at your bank, right? There's 3 tellers here, and there's one line like this. So there's you, here's another person, here's another person. And then you enter the line from the back, right? And then you basically wait for one of these tellers to be free, and then you go there, and then the next person moves up. So here, whoever entered the bank line first gets serviced first. So whoever's first in is the first out of the line. See the difference between the two, right? Okay. So what does this have to do with Java? Well, here in Java, we have this thing called a stack. Now a stack is both an abstract data type, I'll explain what that means in a second, and it's also a concrete class. An abstract data type means it's got certain features. These are the features of a stack. You see there's just not a lot of features. It's a really Spartan data structure, and that's one of the things people like about it. It's simple. It's really simple to use, and it's simple to remember what it does. It can be built using different underlying techniques. We're going to build our stack using an array, because you're familiar with arrays. But you could also build a stack using some sort of fancy list, like a linked list. Well, I haven't told you what that is yet, but we're going to learn about that right after Thanksgiving. Okay? But we're going to, since you already know arrays, we're going to build our stack using arrays. The abstract data type means as long as you provide a certain set of features, how it's built underneath isn't really that important. The user doesn't care about that. The user just wants to see the features. It can be built differently. Now, it's in Java, stacks are also a concrete class. What that means is there's a class called stack in the library, and you can actually say stack s equals new stack. In fact, we're going to do that in just a few minutes. So these are the basic operations that are on a stack. And I want to explain what each of these things does. So we'll get to queues later. I'll describe it briefly on Wednesday when I talk about Masada. Let's talk about a stack. And the stack basically is an array. And I'm going to draw the array like this. And you can think of this stack as like a stack of dishes or something like that. And the way this works is that there's a pointer called the top pointer, and all it does is it tells us where the next element is going to be inserted. So here, top is set to 3. Top is set to 3. And what's happening here is that there's data here, here, and here. And 3 doesn't have any data yet. So if I was going to add stuff to the stack, the next place I would add it would be this location. What would happen to the top pointer after I add stuff? Yes, Mr. Franovic, what would happen? Yeah, it would just go up 1 like that. Now, let's talk a little bit about these basic operations on a stack. This one is called push. This basically lets you add stuff onto the stack, add another item to the stack. And pop is the opposite. It lets you remove something from the stack. When I push, I increment the top pointer by 1. First, I put the stuff in there where top is indicating, and then I move the top pointer by 1. What do you think happens when I pop? Mr. Schulzen, what do you think?
You delete, or you return it and delete it and then move it down by 1.
Yeah. A lot of times we don't even bother deleting it. We just kind of leave it there, but just because we move the top pointer down, the implication is that we're not just, like if there was data here, let's say there's data here, we pop it, right? We'll use this item, we'll return it, we'll move the top pointer here to indicate that this is not really a thing anymore. We won't even bother deleting it because it's just waste of computing resources. Yes, Ben?
Because next push it'll just get overwritten, right?
Right. Next push it'll get overwritten anyway. Okay. All right. So that's that. Can anyone guess what peek does? Peek is similar to pop. Peek is similar to pop. Mr. Alejandro, do you know what peek does, sir? It returns the top element, this one, but it doesn't change the pointer. So if you did a peek again, it would give you the same value. If you did a pop, it would give you the same value. So it's the same as a pop, but it doesn't remove the element from the stack by moving the top pointer. It doesn't do that. Empty, this is a Boolean method, and it's a little confusing because the stack has a method called empty. The object, the classes it inherits from also has a method called isEmpty, and they basically do the same thing essentially, and they return true when. It's pretty obvious. Mr. Orspive?
Is it when the pointer is empty?
It's when the whole stack is empty. When the stack is empty, what is the value of the top pointer? Yes, sir.
0.
It's just going to be 0. So when the top is here, you know the stack is empty. And then clear basically clears out the stack, and all you have to do is what to clear out a stack? Mr. Mariak, what do you do to clear out a stack?
You just have to move the top pointer down.
All you do is you move the top pointer here. We don't bother actually going in and deleting the elements. It's just a waste of time. We just move the top pointer there. We're done. So what we're going to do is we're going to create a stack, and we're going to tell it that it's going to be a stack of integers. And it's a concrete class, so I'm allowed to just create it like that. Now, what I'm going to do is I'm going to show you some basic operations. So we're going to go s.push 1, s.push 2, and s.push 3. Then we'll system out println s.pop. And then we will print what's remaining in the stack. How many lines of output will there be? What will be in the first line of output? What will be in the next several lines? Whatever. Okay, Mr. Nikita, sir, can you tell me how many lines of output will there be? 2 lines. What will be in the first line, sir? 3. And the next line?
1.
Okay, very good. 1, 2 in the second line. Let's run it. So you can see here's the 3. Notice that the output is extremely similar to what an array list looks like. So the built-in toString is pretty much the same for stacks and array lists, and I think it's the same for all collections pretty much. All right, so now I'm going to ask you to do a couple of simple exercises for me. We're going to delete all this, and we're going to create an array list of integers. You know what? Let me do something a little bit different this time. Let's go with decimal numbers. And I'll do decimals here also. And here I'll create a list. And we'll put some numbers in the list. Okay, let's go with list.add 1. All right. And what I want you to do is I want you to print the list. Then I want you to use a stack to reverse the list. And then I want you to print the list again. Stacks are extremely useful for reversing things. They come out in the opposite order that they went in. So it's useful. Stacks are useful for reversing things for that reason. Okay, let's do a for loop. Okay, go ahead. Let's do a while loop instead. What would be the condition on the while loop here? What do we want to do while it's not empty? I want to put them back in the list, sir. So we should do something with the list here. What would be the best thing to do with the list? That's not the only way to do it, but that's one way. We could also overwrite the elements with a set command instead. That would be another way to do it. I think this is a good way, though. And what's the last thing it said to do? Print the list. So we'll just go like that. So here I'm loading up the stack. I'm clearing out the old list, and then I'm reading from the stack and putting it back into the list. And that will essentially reverse my list. So now let's run it. And you can see the list has been reversed. So that's a really useful thing for a stack to be able to do.